Alright, welcome to my YouTube channel. Now this is A Square Maths Made Easy Academy. So in my today's video, we are continuing with calculations in calculus. This one is part 2 aspect of it. In my first video, I was able to solve question number 1, 2, and 3. So what I'm trying to do is to hit a target of 100 questions under calculus. Now we are continuing with the next question, which is question number 4. Now this is A Square Maths Made Easy Academy. Now I want you to please subscribe to my channel. I also want you to comment in the comment section, share, then like. Thank you so much. Let us look at question number 4. Now what does question number 4 talks about? The question says, find the domain and range of f if f of x is equal to square root of 1 minus x squared. Now these are the options. Yeah, let's work on question number 4. Now what we're given is f of x is equal to square root of 1 minus x squared. Now how do we identify the domain of this first? The first thing we are going to do here is to consider this value now, which is x. Now you find out that if you observe this time around x is squared. So which means if I start with the least number of real number in between, which is 0. Now the question is, can I get the range? I believe so. So if you say let x be equal to 0, it's going to give me square root of 1 minus the x is 0 square, which is 0. And I will continue to have square root of 1 minus 0 will give you 1. And square root of 1 is 1. It exists. So which means when the domain x is 0, the range is 1. Then after that, if I increase this now to 1, can we still find the range? Yeah, let's solve it. This is now square root of, I have with me 1 minus, then I've seen x is 1, and it is squared. So 1 squared will give you 1. So if you simplify further, you have square root of 1 minus 1 will give you 0. And square root of 0 is 0. It's still range. So which means when x is 1 as the domain, the range is 0. Then the next thing, if I increase x to 2, you find out that such does not exist. Do you know why? By the time I substitute, I'll be having square root of 1 minus x is 2, but all squared, and 2 squared should give you 4. So this is now equal to square root of 1 minus 4 will give you minus 3, which means square root of minus 3 does not exist. So if I continue with x equal to 3, it's still the same thing. So what I'm going to do now is to narrow down to negative values. Let's start with x equal to minus 1. So I'm going to have square root of, this is 1, right? Minus, what is x? X is minus 1, then all squared. This is now square root of 1 minus 1 squared. The minus will disappear to give you 1, and it becomes square root of 1 minus 1 is 0, which is square root of 0 is still 0. Are you with me? Now if I continue with x again equal to minus 2, decrease to minus 2, you find out that the function does not exist. Do you know why? By the time I introduce x to be minus 2 and square it, the minus will disappear. It will now become 1 minus, then minus 2 squared should give you 4, and 1 minus 4 will give you the same thing here, which does not exist. And the same thing applicable to when x is minus 3. It will still not exist. Can you see that this particular function is not bounded by negative infinity and positive infinity? It's just within the range, within the range. Now with this now, I can determine the domain. I will now say domain of f, and this one is range of f. Then what's the value of domain of f? They are we have 0, it exists. We have 1, it exists. This one does not exist. minus 1 also what exists. This one does not exist. So which means the only value that exists as far as domain of f is concerned is 0, 1, and what? Minus 1. Then we now move to the result. When x is 0, what is the range? The range is 1. Now when x is 1, what is the range? The range is what? 0. And finally, when x is minus 1, what is the range? The range is also what? 0. Now let's get the domain. In here, I will now say domain of f is now equal to, now identify the least value among here. What's the least value? The least value of x is minus 1. So I will now introduce block and put minus 1, comma. Then what is the highest value? The highest value here is what? 1. So I will now introduce 1 with what? Block. Now this is the domain of this very particular word function. Then we now move also to range of what? F. Now range of f is this. What is the least value of the range? It is what? 0. I'll use block and introduce what? 0. Then what's the maximum value of the range? It is 1. I'll introduce 1. Then use what? Block. Now this is the final answer. The domain is block minus 1, comma 1 block. And the range is what? Block 0, comma what? 1 block. Now can we check the options here? Option A says bracket minus 1. No. Option C says this is the domain and this is the range. No. Option C says bracket minus 1. No. Then option D says block minus 1, comma 1 block. And the range is what? Block 0, comma 1 what? Block. So which means the correct answer in the option is option what? C. Do you understand? Now can we move to question number what? 5. Question number what? 5. Now what is question number 5 talking about? I want you to watch. Number 5 says, if f of x is what? A raised to power sine x. Now find f prime of what? X. Now this prime means what? Derivative, or you can call it dy over what? Dx. Now let's tackle question number what? 5. We're given that y is a raised to power what? Sine what? X. And the question is to find dy over what? Dx. Now watch this. Remember that f of x is same thing as what? Y. Now this type of problem, I'm going to use the normal method, which we call differentiation by what? Chain rule. Why is it chain rule? Because this is a single function with an exponent, which is the power. So had it been that here is x now, x a raised to power, it would have not been what? Chain rule. We would have used what we call product rule. Do you get? But if it is all over what? X, we use what we call what? Quotient what? Rule. Now, which means the criteria is that we are going to use what we call differentiation by what? Chain rule. I say differentiation by what? Chain rule. Now, what is the general formula for chain rule? Now, the formula says dy over what? Dx is equal to du over what? Dx. Then times dy all over what? Du. This is chain. Now, if you observe this now, when du cancels du, what remains is dy dx to the right, which is also equal to dy dx to the what? Left. Now, let's go. Now, the question is that, which one am I going to consider as u? Let u be the power always. Remember what I said. U is the power. And what is the power? Sine what? X. So what are we differentiating now? U with respect to what? X. I'll get du all over what? Dx. Then equal to. Now the rule of differentiation by trigonometry listing is that anytime you are looking for the derivative or dy dx of sine x, the result is always what? Cos what? X. So I've gotten du over what? Dx. Are you with me? So the next thing I will say now, let y be what? Y is now the constant, which is a raised to power what? U. It is no longer x. A raised to power what? U. Do you know why? We want to differentiate y with respect to what? U. And I want you to be very, very careful in this aspect. Now, anytime you encounter a constant down and a variable up, please, what you should do is to take the logarithm, first of all, of both sides, the natural log of both sides. How? I will consider this as ln y. Are you there? Then equal to. Then this one should also be ln what? A raised to the power of what? U. That is how it's being done. Now, this thing has obeyed the laws of log reading. Remember that another way of writing this is what? Watch. I will say log y exponential then equal to, I will say log what? A raised to power u what? Exponential. Can you discover that this particular value, as the law of log reading implies, u will come down? So which means I will now have ln y then equal to u will come down, becomes u then ln what? A. Am I communicating now? Now the next thing is to differentiate ln y and differentiate u ln what? A. Now how do we differentiate ln y? In my previous video I just made as a single derivative. Anytime you are differentiating ln means 1 over the variable that, and that is y. That's the first thing. 1 over what? That, which is 1 over y. Are you with me now? Now after that you multiply and now differentiate that, and that is what? Y. So if you differentiate y, it will give you 1. Am I communicating now? It's just like somebody asking you differentiate x. What is x? 1. Then having differentiated that, don't forget to put the y all over what? The x. Do you know why? Anytime you are differentiating y, remember to put the y, the x. The reason is because y is a function of what? X. So which means if I'm differentiating this, I will now say 1 over y first. Then I will multiply. Differentiate y will give me 1. Am I communicating? Then because we are differentiating y and y depends on x, we always put the y all over what? Dx. Now this is now equal to. Now the next thing is to differentiate u, because this is a variable that we're talking what about. Now watch. How do we differentiate u? U is still what? 1. Identifying the derivative of a variable, just x or y. So this is u, right? U raised to power 1. And if you apply the rule of differentiation, it's going to give you 1, which I've been doing. So which means if you differentiate u, it will give you 1. Then 1 times the ln a will give you ln what? A. Are you with me now? Now if that is done, the next thing is, what are we going to do now? Well, I will now say 1 times 1 will give us 1 over y. Then dy all over what? Dx. Then equal to ln what? A. My target is to make the y, the x subject of the word formula. But I want to take you back again. If you observe this, we are differentiating y with respect to what? U. So which means at this process now, I beg your pardon, it's going to be dy over what? Du. This one is also going to be what? Dy over what? Du. We have understood the analysis. Then what is my target is to make dy du subject of the word formula. I will multiply both the left and the right by what? Y. So that I can say 1 over y, then times y. Are you with me? Now dy all over what? Du is now equal to what is here? Y. I multiply both sides by y, then ln what? A. Then y down, we cancel y off. Then 1 times dy du will give us dy all over what? Du. Then equal to y ln what? A. Am I communicating? Now the question now is this. Since we have done this now, so what is the next thing? Is now to go to the value of the chain rule. I mean the formula for the chain rule and substitute. Now watch. But my question is this. I want to ask you a simple question. Do we know the value of y? Look at it here. What is y? Y is what? A raised to power u. I will now say this is what? A raised to power u. Then ln what? A. Let's go back to the formula. Dy over dx. Are you there? Then equal to. What is the value of the u dx? It has been solved. The value is cos what? X. Cos what? X. Then the next thing is dy du. Look at it. Dy du. What's the value? A raised to power u. A raised to power u. Then ln what? A. Finally, substitute for what? U. Do we know the value of u? I believe that is from this now. U is what? Sine x. So in summary, dy over what? Dx is now equal to cos what? X. Then a raised to the power of u. What is u? U is sine what? X. Then finally ln what? A. This is the final what? Answer. Now let us check if this one answer is in the option. This is cos A. This is cos x, I mean to say. What is here cos x? This is a raised to power sine x. What is here a raised to power sine x? Oh my goodness, this is ln 2. So it cannot be this. Now look at it. A raised to power sine x. A raised to power sine x. What is here cos what? X. What is here cos x? And finally, what is here? Lane X. And what is here? Sorry, lane what? A. And what is here? Lane A. So which means the correct answer in the option is option what? B. This is what we call using the general word formula. But do you know that I can hit this question using what we call shortcut in just less than what? A minute. Can we approach it now? I want you to watch. Now let's move. What is the next thing? I want to use shortcuts now to solve this. At least for the interest of those that are solving what? CBT. That are using CBT. Now watch this. I want to give you the steps. It's very simple. Now the first step, look up, is to, number one, is to differentiate. Differentiate. What did I say? Differentiate the word power. That is the first step. Then after that, the second step, are you with me now, is to repeat the word question. What did I say? Repeat what? The question. Then the third step, are you with me now, is to take what? Lean of what? The base. Lean of what? The base. Now let's go differentiate the power. What's the power? Sine x. If you differentiate sine x, what is the answer? Cos what? X. Now the second thing is repeat the question. What is the question? The question is a raised to power what? Sine what? X. Are you there? Then lastly is to take the lean of the base. Here this is the base A. Call it lane what? A. That is all. Can we now say finally dy all over what? Dx, which is empty as f prime of what? X is equal to what is here? Cos what? X, right? What is here? A raised to power sine what? X. And what is here? Lane what? A. Is there anything like that? Let's observe it. A raised to power A, what is it? The option D. I take it again. Yes, what is here? Cos X. What is here? Cos X. What is here? A raised to power sine X. A raised to power sine X. What is here? Lane A. What is here? Lane A. This is the correct answer using what? Shortcut. So which means it is option what? B. Now let's move to the next question, which is question number 6. I say question number what? 6. How do we solve this? I want you to watch. Question number 6 says, given that f of x minus 3 is equal to x squared plus 3x minus 1. Now the question is this, look up, sorry. Find what? F of what? 1. That is the question. Find what? F of what? 1. Now, let us observe this. We are given f of x minus 3 as equal to x raised to power 2, then plus 3 what? X, then minus 1. Now, do you know that people that looks at this question, some to some, we just already says that x is already given because this is f of what? X. They will not go directly and substitute. Now, if you do that, let's observe it. When x is what? 1. 1 squared will give you 1, right? Then plus, now this is 1 again. 3 times 1 will give you 3, right? Minus 1. At the end, 1 plus 1 will give you 4. And 4 minus 1 will give you 3. Do we have 3 in the option? Yes, but that is wrong. Do you know why? There is minus 3 here. But had it been that the question is exactly f of x like this, I would have concluded that if x is what? 1. I cannot substitute, and at the end, what I will get here is what? 3. But here is what? Minus 3. Are you with me? Now, how do we solve this problem? First of all, we get the actual value of x. How? We compare the question. We say let f of x minus 3 be equal to the f that we're looking for, which is what? F of what? 1. The essence of doing that, compare the two functions, is to get the value of what? X. Now, f here we cancel f. So which means x minus 3 should be equal to 1. Can I make x subject now? So my x will now be 1. If minus 3 move over, it becomes plus 3. And what is the answer 4? Now let's go back to the function and substitute. So what do we have now? F of, what is x? 4 minus 3, right? Then equal to, what is x? 4 what? Squared. Plus what? 3 bracket what? What is x? X is 4 minus 1. Can we say f of 4 minus 3 should give you 1, right? So which means this one becomes f of 1. What is here? F of 1. Can you see it is balanced? Then let's move. 4 square will give you 16 plus 3 times 4 will give you 12. Then minus what? 1. Can we say 16 plus 12 will give you 28? And 28 minus 1 will give you 27. Do you have 27 in the option? Wow. The correct answer is option what? A. Have I made myself clear? Now let us see the last question, which is question number what? 7. Question number what? 7. Number 7, let's see it. Verify if f of x equal to 4x minus 3 is an onto function, also one-to-one function. Now there is what we call one-to-one function, and there is what we call onto what function. So we want to verify if f of x, which is equal to 4x minus 3, is what? Onto first. Now the question, what is an onto what function? That is the question now. And what are the characteristics of solving an onto what function? Now let's just solve something like that. Watch, observe something like this. Let f of what? Domain of f, are you with me? Be a subset defined in real number. Map what? Y. And y is a subset defined in what? Real number. Are you with me now? I take it again. Let f of domain of f be a subset defined in real number. Map y, and y is a subset defined in real what? Number. So now, which means a function is said to be what? Onto. Are you with me now? If small y is a member of big Y, I take it again. If small y is a member of what? Big Y, there what exists. X is a member of domain of what? F. X is a member of domain of what? F. Now such that f of x is equal to what? Y. Such that f of x is equal to what? Y. Now if you define this, it is called an onto what function. Am I communicating now? Now let's prove it now. Let's verify if it is onto or not. Am I communicating? Now let's start. Do you know the condition of an onto function is that f of x should be equal to y, right? Now, from the question, are we given the value of f of x? Yes, f of x, look at it here. It is 4x minus 3, which is equal to what? Y. Anytime you are given something like this, the first thing you are going to do is to make x subject of the word formula. Then I'll take out this minus 3 here. It will now remain 4x is now equal to y. If minus 3 should move over, becomes plus what? 3. So what is my target is to make x subject of the word formula. I will divide by 4. I will also divide by what? 4. 4 will cancel what? 4. So x is now equal to y plus 3 all over what? 4. This is the value of x. Now let's take off the question again. Remember, we said f of x, are you with me now, is given as 4 what? X minus what? 3. Mind you that we have gotten the value of x. This is the value of x. Can we substitute on both sides? Let's go. This is f, right? Of what is x? Y plus 3. Then all over what? 4. Close the bracket. Then this is now equal to, I have with me 4 bracket. What is x again? Y plus 3. Then all over what? 4. Close the bracket. Followed by minus what? 3. Are you with me? Do you agree with me? What is y plus 3 over 4? Look at it. Y plus 3 over 4 is what? X. So which means I can call it f of what? X. Are you with me? Then this is now equal to 4 down here, we cancel 4 up here. It remains y plus 3 followed by minus what? 3. Plus y will disappear with minus y. Can you see that? In summary, what did I say? In summary, look up that f of what? X is now equal to what? Y. Does it prove this now? Yes. So which means since f of x is equal to y, we can say hence f of x, which is equal to 4x minus 3, is an onto what? Is what? An onto function. And it has been proved. Have I made myself clear? It has been verified. Now the second stage again we're going to do is to talk about what we call one-to-one function. What we call what? One-to-one function. Now I will claim this and we're going to verify if this is also one-to-one. How? Then I want you to watch. F of x is given as 4x minus what? 3. Want to verify is one-to-one what function. Now the same thing applicable here. Let f of what? Domain of f be a subset defined in real number. Map y, and y is a subset defined in the what? Real number. I will now say a function is said to be 1 to 1. Are you with me now? A function is said to be 1 to 1 if f of x is equal to f of y, which implies that x is equal to what? Y. Or otherwise, if f of x is not equal to f of y, it implies that x is not equal to what? Y. This is the definition of what? One-to-one function. Now let us verify it now. Remember, we are to verify f of x equal to 4x minus 3. Later it is one-to-one function. Then what is the characteristic of one-to-one function is that f of x is equal to f of what? Y. Are you with me now? Now in subjection, are we given f of x? Yes. What's the value? The value is what? 4x minus 3. Are you there? Then equal to. Now at this point, this is now f of y. So remember that x is equal to what? Y. We still go on this expression now. What is it? So this is 4, right? And what is x? X is what? Y minus what? 3. So now can we say this is 4x, right? Take minus 3 to the right. It will now become equal to 4y minus 3. And as minus 3 is moving to the right, it becomes plus what? 3. Then in summary, minus 3 will disappear with plus what? 3. So what remains now is 4x equal to 4 what? Y. So what do you think that will happen here? Divide this by 4. Divide this by 4. 4 will cancel 4. 4 will cancel 4. And this implies that x is equal to what? Y. Does it prove the concept? Yes. Now, if it is that, we can now say since f of x, if f of x is 4x minus what? 3. Now, and it implies that x is equal to what? Y. We can now say that hence f of x, which is equal to 4x minus 3, is a one-to-one, is a what? One-to-one what? Function. Have I made myself clear? Now, this is exactly what you see as far as one-to-one and onto function is concerned. Have I made myself clear? Please, I want you to subscribe to my YouTube channel. In my next video, I will continue with question number 8. Remember, I'm treating first 100 questions under what? Calculations in calculus. See you. Thank you so much.